Okay, let's take a look at independence from an algebraic point of view. So now here's the assumption. Let's suppose that A and B are independent events. Well, let's recall the formula for conditional probability. The formula of conditional probability is B given A is equal to the probability of A and B all over the probability of A. So here, let's treat the probability of B given A as an algebraic quantity, and we know that if we divide by 1, that's not going to change the value of this expression. Now here we have something called a proportion. We have a ratio equaling another ratio. Whenever we have that, we can do something called cross multiplication. So I can multiply the probability of A times the probability of B given A. And we can do the same with 1 and multiply it times the probability of A and B. So we have 1 times the probability of A and B, and now we have this equation. But now, since we assumed that A and B were independent events, we know that the condition of A will not affect B. So in this scenario, we can say that the probability of B given A is simply equal to the probability of B, because again, A has no effect on B since these two events were under the assumption that they are independent. So let's make that substitution. We have the probability of A times the probability of B, and that's going to equal 1 times the probability of A and B is just the probability of A and B. And here we have the test or the algebraic definition. Two events are independent if the probability of A times the probability of B is equal to the probability of A and B. And here I wrote a little bit more formally. Two events are independent if the probability of A and B is equal to the probability of A times the probability of B. So let's do some examples, or let's do one example using this formula so you can finish the rest of this assignment. So here, example 3. Use the given probabilities in order to determine independence. So let's draw our skeleton here. So our new formula says that the probability of A and B must equal the probability of A times the probability of B. And if we get the same thing on both sides of this equation, then we can say that the events are independent. If the left-hand side does not equal the right-hand side, then we say the events are not independent. So let's see what happens here. Probability of A and B, that's equal to 3/5. So we are done with the left-hand side. For the right-hand side, now let's substitute the probability of A, which is 1/2. So we have 1/2 multiplied by the probability of B, which is 3/10. So we have 3/10. So 1 times 3, that's going to give us 3. And then 2 times 10, that's going to give us 20. So we have 3/20 equaling to 3/5, and this is not true. So we say that the events are not independent. Now, if you are very, very unsure because you hate fractions, you can also put this in a calculator. So 3/5, that's going to be 60%. And then here, 3/20, we get a total of 15%. So you can see how these two do not equal each other. Okay, so finish this assignment and I'll see you on tomorrow's lesson.